To find the consumer's surplus, we integrate the demand function. Demanding products is what consumers do. I'm going to put a dx here. It's always an integral from 0 to an x coordinate, and then it's minus the x coordinate times the y coordinate of a point. In this problem, we're going to integrate the demand function, which is x minus 6 squared. I'm making all the q's x's, dx, from 0 to the x coordinate. And then after this integral, it's minus the product of these two numbers, the coordinates of that 0.39. X minus 6 times itself is x squared minus 12x plus 36. I'm going to integrate that from 0 to 3. And then after we get the integral, we subtract 27. That's 9 times 3. The integral of x squared dx is x to the third over 3. The minus and the 12 get copied. The integral of x to the first dx is x to the second over 2. Copy the plus, copy the 36, and the integral of dx is just x. Bracket there with numbers attached, and minus 27. All the x's get replaced with 3. So it's 3 to the third over 3 minus 6, because 12 over 2 is 6, times 3 squared plus 36 times 3. All the x's got replaced with 3's. And then minus, when x is 0, we have every term is 0. 0 minus 0 plus 0. But we still have the minus 27. 3 to the third is 27. And 27 divided by 3 is 9. 3 squared is 9. 9 times 6 is 54. Plus 36 times 3, that's 108. So on my calculator, I'm calculating 9 minus 54 plus 108 minus 27, and I got all that is $36. To find the producer's surplus, we integrate what producers do. The producers supply goods, put a dx there, from 0 to an x coordinate, and the product of the x and y coordinates goes in front here like this, x minus y times that integral. X times y minus the integral. The x and y are 1 and 4, x times y minus the integral from 0 to the x coordinate. In this case, the supply function is given. It's x squared plus 2x plus 1. So here we have 1 times 4. And this integral is, the integral of x squared dx is x cubed over 3 plus 2 gets copied. The integral of x dx is x squared over 2 plus the 1 gets copied, and the integral of dx is just x. We put a bracket here with the 0 and the 1. But this is a little tricky because it's minus whatever number we get doing this. So we should figure out that number and then worry about the 4 minus later. All the x's get replaced with 1's. 1 cubed over 3 plus 1 squared, because I canceled these 2's, plus 1 times 1. And then it's going to be minus 0, because when we replace x with this number down here, we'll have 0 plus 0 plus 0. One to the third over 3 is 1/3, plus 1 plus 1. I'm going to change 4 to something over 3. 4 is 12/3. Then we have minus 1/3 minus 1, which is 3/3, minus another 1. So 12 minus 1 is 11. 11 minus 3 is 8. And 8 minus 3 is 5. So that's 5/3. And 5 divided by 3 is approximately $1.67. That's 5 divided by 3. Did that on my calculator. Equilibrium point is when the demand and the supply are equal. So that would be when Q minus 4 squared is equal to Q squared plus 2Q plus 6. And when we square Q minus 4 times itself is Q squared minus 8Q plus 16 equals Q squared plus 2Q plus 6. If we subtract Q squared from both sides, we get negative 8Q plus 16 equals 2Q plus 6. And subtract 2Q from both sides, negative 8Q and negative 2Q is negative 10Q. And subtract 16 from both sides, 6 minus 16 is negative 10. Divide both sides by negative 10, so Q equals positive 1. And when we put 1 into either of these, I'll choose this one. 1 minus 4 squared is positive 9. So the equilibrium point is the x coordinate is 1 and the y coordinate is 9. The consumer surplus, we integrate what the consumers do, they demand, from 0 to the x coordinate, which is 1. I prefer to use x instead of q, even though I could use q. So then I can put a dx here, and then it's minus the 1 times the 9, the product of those coordinates. Well, x minus 4 squared is, we figured it out over there, is x squared minus 8x plus 16. We're going to integrate that from 0 to 1. And don't forget dx. And after we get that value, we're going to subtract 1 times 9. The integral of x squared dx is x cubed over 3 minus 8. The integral of x dx is x squared over 2 plus 16. The integral of dx is just x, 0 to 1. All the x's get replaced with 1s. So we have 1 to the third over 3 minus 8 times 2 is 4. 8 over 2 is 4, but it's 4 times 1 squared plus 16 times 1. And then minus 0, because 0 minus 0 plus 0. So it's 1/3. On my calculator, I'm doing 16 minus 4 minus 9, which is positive 3. 3 plus 1/3 is 3 1/3, which is, in money, $3.33. So we don't have that last answer yet, but we're going to get it now. So 1.9 is the equilibrium point. $3.33 is the consumer surplus at the equilibrium point. And now to get the producer surplus, we start with the x times the y, coordinates of that point, and then subtract the integral of what producers do. Producers supply. This is the supply function. It's x squared plus 2x plus 6 dx, and that's from 0 to 1. It's always 0 at the bottom, and the x coordinate of the equilibrium point on the top. The integral of x squared dx is x to the third over 3. Copy the plus, copy the 2. The integral of x dx is x squared over 2. Copy the plus, copy the 6. The integral of dx is just x, 0 and 1 attached. At the beginning of this formula, I have 1 times 9 minus whatever that comes out to be. So I replace all the x's with 1s. I have 1/3 plus 1. These 2's cancel. Plus 6. And then minus 0. The other number is 0. We'd have 0 plus 0 plus 0. So whatever that comes out to be, it's got to be 9 minus that. Actually, I could distribute the minus and make it 9 minus 1/3 minus 1 minus 6. 9 minus 1 is 8, and 8 minus 6 is 2. So 2 minus 1/3 in money, that's $2. I mean, that's $1.67.